peux le faire un peu.
Ah, je peux faire un trou.
Il a compris, voilà.
Oui, je peux faire un trou. Alors là, en fait,
Moi,
j'ai une question pour toi. Moi, je vais être à Munich le 1er ou 2 octobre. C'est la semaine avant le 25. Alors, ça, si on veut fouetter les troupes, on pourrait faire si on veut fouetter les troupes, c'est correct. Si on veut fouetter les troupes, on peut faire le moment de 26 chez toi. Ah, on peut faire autre chose. Les gens qui sont en Russie, si on regarde le 25-26, on devrait mettre sur le
25, c'est oui, c'est ça.
on met sur le
25, c'est marrant.
Moi, de toute façon, j'aimerais. J'ai pas acheté mon travail. Donc, de lundi, mardi, je vais être à Munich chez vous. Donc, la semaine, de toute façon, moi, je m'en vais d'être chez toi.
Bon, ça va.
On a parlé la fois. Question de fouettage, je trouve.
C'est bon.
On va leur donner quelques minutes. Je l'ai lu, la présentation, j'ai pas besoin. Ok, alors il faut que j'ouvre le micro pour faire la présentation? Ouais, ok. Tu changes les slides pour moi?
Ouais.
Ok. So we'll start slowly. I think we're going to get more people. The problem that we have right now, we're in parallel with the MapRG, where some of the people are interested with this group are also interested by that group. So I think we're going to see a lot of moving in and out, and but not to delay the people who are online to do some presentations. We'll start. So this is the Coding for Efficient Network Communication Research Group. I'm Marie-Josée Montpetit, and the other co-chair is Vincent Roca. And so what do? We essentially are looking to foster research and network and application layer coding to improve network performance. And our goals are also to look at the codes themselves and the coding library, which was essentially what started this group. And we have had a number of efforts in that. We're looking to protocols that help in the use of coding in existing systems. And a lot of the codes that we have considered combine both protocols and coding. And this is a very good thing. And we look at real-world use cases and work in progress, and you're going to hear a lot of that today. Obviously, there's the note well, and I see Kerim here, and I know you guys still need, I guess, to update some of your IPR. I've been told that some of them were expired, but anyway, I will give you an action item to look into that. I think the rest is fine. So if anybody else has IPR in this field, please disclose it. And there's the forms on the web. This is just stuff that you can read, so I don't have to go through this. So what are we going to do today? After I'm finished talking. So we're going to have a presentation remotely from Hong Kong on the BATS codes. Those were presented, I think, in 2015, but there's a big update, and Raymond will talk about that. We want to have a discussion on symbol signaling and FEC schemes. And I took a typo there, but that's fine. And because Vincent and I think other people have found that maybe there's a better way to make progress in this, especially with the current draft that's called the Draft HIDE Network Coding Research Group, or LNC. And it made us really think that maybe we needed to give some attention to this. Vincent will present his API for the sliding window FEC codes. We're going to have, obviously, the feedback from the transport working group, where actually the code itself was presented as an extension of the previous work on FEC frame. There's going to be a question, and I see that Brandon is there and Emmanuel is online, because the three of us were supposed to do something about network coding and congestion control, and we haven't done it, so we're going to talk about that. Next slide. Then there's going to be, Ian is going to come to talk about the work that is ongoing on the coding for Quick. We've made a lot of good progress there. And yesterday at the Quick meeting, they said they were starting to look at the next type of work once the current version of Quick is going to be finished, and they've also defined a new type of frames inside Quick, which is very good for us doing coding. The people online, Nicholas and Emmanuel, will do a quick status on the network coding and satellite. This is actually pretty stable, and one question will be, should we accept it as a research group item? Hitoshi and Cedric are not there on the ICN one, but there's also, I think that is also very stable work. And then what's next? We're thinking of an interim in mid-September, and thank you to the ICNRG people to have actually advertised that it was the 25th. It may be the 26th, but it's around there. It could be in Boston in virtual meeting, but we're also thinking we could make it in Europe to accommodate the other people here. And we do plan a hackathon for IETF03 in Bangkok. So, Raymond, are you there? Oh, I'm not finished. Sorry.
Yes, I'm
no,
ready.
Raymond, I'm not finished. I thought it was the
okay.
Yeah. Okay. So, in achievements, we had our first RFC. Yay. It's all the taxonomy, so now we know what you were talking about. Next. So we have a number of active IDs. We have the Tetris ID, which, again, we're going to talk a little bit. We're not going to talk about it, but we would like it to make some progress, so we could accept it as a research group item. We have the draft IDA that I mentioned, the coding and satellite, the content-centric. I did mention all of this, the API, which is actually what Vincent is doing, and what Ian, Vincent, and I are doing for Quick. We had some milestones. Yes. Yeah, we could wait for the milestones at the end so that we can actually go to the people who are online waiting. So, Raymond, now it is your time.
Yes.
Okay, thank you, Marie-José, and Vincent, thank you for accommodating my talk. So, yes, please play the slides. That is the last one there. Okay, can you guys hear me?
Yeah, perfectly.
Okay, very good. Okay, hi everybody. My name is Raymond Young from CHK. I gave a talk on Bash code some 4 years ago, and during the past 4 years, there have been a lot of progress in the development, and so I'm giving another talk on this subject. Next slide, please. Okay, I'm going to talk about something called the, sometimes referred to as the multi-hop curse in industry. It is well known that in a wireless multi-hop network, the throughput drops very drastically after 3 or 4 hops, namely that the throughput is very negligible after 3 or 4 hops. And that is why we don't see very often wireless networks with more than a few hops. However, wireless networks with many hops are emerging in many different applications, as we are going to see. Next slide, please. Okay, one of them is the application to smart lamppost. This picture shows a number of smart lampposts in a urban area. Okay. Now, ideally, we should be able to connect a fiber to each of these smart lampposts so that they can be connected to the internet backbone. But in a developed city like Hong Kong and also many other cities, it is not quite possible to do so. The reason is not only that it is expensive to lay fiber, but also that it takes a very long time, something like 2 to 3 years to apply for all the permits to do that. Okay, so one possible solution is that we connect an optical fiber to some of the lampposts, and then we use a wireless multi-hop network to connect the nearby lampposts to that access point. Okay. Now, on these lampposts, there we can put a lot of things on them. For example, we can put sensors for weather conditions, for air quality control, for real-time traffic conditions. And I would like to mention specifically one thing that will be put on these lampposts, namely 5G base stations. As we all know, for 5G, we are going to transmit in millimeter wavelengths, which means that the transmission is very directional. And as a result, we need to put to deploy a lot of 5G base stations. Okay. Now, one very natural place to put these base stations are the lampposts. So after putting the base station there, then the following question arises: how are you going to connect these base stations to the internet backbone? And that's the solution that I just talked about, namely that using a multi-hop wireless network would be a very natural candidate solution for this problem. Next slide, please. Okay, another example is a wireless ad hoc network where we have a multi-path situation, a multi-hop situation very naturally. Next slide, please. Okay, another example is satellite communication networks. There are companies which have plans to launch thousands of satellites to cover the globe to provide high-speed internet access. Next slide, please. Another example is just a V2X example, which we are all very familiar with. Next slide, please. Okay, yet another example is underwater acoustic communication. We talked to some people working on the underwater communication, and I learned that the communication environment there is actually very volatile. No matter what coding scheme you use, what modulation scheme you use, the packet loss rate got to be very high. Okay? So it is actually very challenging to build such a network with 5 hops. Next, please. Okay. In order to break this so-called multi-hop curse, next please, we introduce BATS code. Next please. What is BATS code? It is an advanced network coding technology developed in my group at CHK, and they are ideal for multi-hop networks with packet loss. Next please. BATS code transmits coded packets in batches, which is a parameter that can be tuned. A small number of batches are stored and recoded at every relay, and BATS code can dramatically increase its throughput in a wireless multi-hop network. Next, please. Okay, I'm going to show you an illustration which makes a comparison between BATS code and founding code. Here we assume that the packet loss rate is equal to 20% on each hop without retransmission, and the file size is equal to 16. Please play the file animation .mp4 in full screen. Okay, in this animation, okay, in this animation on the top we have founding code, and at the top and the bottom we have BATS code transmitting a file from left to right. Okay, now on the top for founding code, because each relay is doing store and forward, whenever a packet is lost, there's no packet to be forwarded to the next hop. At the bottom, for batch code, here we use different colors for different batches. Here the batch size is equal to 4. Okay? So we see that whenever a new batch comes along, it replaces all the packets in the buffer at the intermediate node. Also observe that when there's a packet loss, we use the packet stored in the buffer at the next relay to generate a new packet to be forwarded to the next hop. Because of this, we can transmit more information through the network. Now, this illustration illustrates what we call the inner code of batch code. There's something which is not illustrated in this animation, which is the outer code, which is something that is performed at the source node and also at the receiving node. So this keeps going, and we see that on the top, there are only 6 packets received, and at the bottom, for batch code, there are already 13 packets received. Once we got to 16, then the decoding can be done. Okay, file decoded. Okay, next page, please. Okay, we also have done quite a bit of prototyping, and the one that I'm going to show you is a video streaming between 2 PCs through 10 Raspberry Pi 3, which is a very popular platform for IoT. Okay, as there are 10 relays, we are talking about 11 wireless hops with significant packet loss due to interference. Please play the file configuration.mp4. In this prototype, we have a PC with a webcam pointing to our direction, and the video stream would go through 10 of these Raspberry Pis, and finally the video stream arrives at another notebook computer with 2 windows. We are making a comparison side by side between batch code and founding code. Okay, okay, we are going to make a performance comparison between batch code and founding code. Please play the next video file. So we are running batch code and founding code side by side. On the left-hand side is the window for batch code, and the right-hand side is the window for founding code. As we can see, on the right-hand side, because there's packet loss on every hop, although it may not be very significant, but after 11 hops, the throughput actually is very low, and that's why the picture is not really moving. In particular, for video transmission, when you hit the I frame, then all the P frames cannot be decoded. Okay, next slide, please. Okay, here are the benefits of batch code. First, high throughput. Second, low latency. And the third is a low coding complexity and also low storage requirements. The latter 2 features makes batch code highly implementable, even for devices like IoT devices. For existing solutions, they fall short on each of these, on at least one of these features. Next, please. Okay, batch code is ideal for multi-hop transmission with packet loss. it can sustain tens or even hundreds of hops with no significant drop in throughput. Next, please. Okay, here's a plot of the throughput versus the network length, namely the number of hops. And there are different graphs here from bottom to top, and that corresponds to a parameter M, which is the batch size from 1 to 64. For batch size 64, the complexity is still relatively low, so it can be implemented in a real device. And as we can see from the top graph, okay, now in this network, we assume that there's a 20% loss on each hop, so that after even one hop, the maximum throughput you can get is 0.8. So you see that after 50 hops for M equals 64, you can still get a throughput approximately equal to 0.7, which is like a 12% drop from the capacity. Next, please. Okay, the next slide shows the throughput versus the number of hops up to 1,000 hops. Okay, let's take a look at the top graph, which shows that after 1,000 hops, you still get a throughput approximately 0.65, which is a 20% down from the capacity. Next, please. Okay, so in a nutshell, BASCO essentially converts a multi-hop network into a single-hop network. It can be an enabling communication technology for many different things, including IoT, 5G, satellite networks, underwater communication networks, power line communication networks, and also for vehicular communications. Next, please. Okay, thank you very much.
Okay, thank you, Raymond. Questions?
Hi, Dave Oran, Network Systems Research and Design. You didn't compare the overhead and bandwidth between BATS codes and competitive codes. Can you just give us some, first of all, can you give us some sense of what that is? And second, is your loss model purely wireless loss, or do you consider congestive loss as well?
Okay. To answer your first question, can you repeat your first question? You said that I didn't. You would like to see a comparison between what and what?
Bandwidth utilization of BATS versus competitive codes. In other words, how much total bandwidth it uses for the coded data?
For overhead.
Yeah, overhead.
Oh, okay. Actually, the overhead of BASCO is very small because I didn't have time to explain that, because the outer code is actually a matrix founding code. Okay, we all know that one problem for random linear network coding in terms of implementation is the relatively large overhead for the coding vector. But because in our case, the outer code, we use a matrix founding code, we actually can implement it using a pseudo random number generator, which takes a very small overhead. And the inner code is linear network coding, and because of the block size, because of the batch size is very small. Like in the case of M equals 64, which means that the block length is equal to 64 symbols. So the vector, the coding vector overhead is actually very small. Now, the second question. Okay, the second question is whether it can be used when the packet loss is not due to noise, but due to congestion. Actually, the question is yes. BASCO does not care how the packet loss are being generated.
Yunfei Zhang, Tencent, interesting job. And I have two questions. First, so is it easy to deploy the BAS code in something like AP, the commercial AP? So is there any difficulty?
Can you repeat your name for the note taker, please?
Yunfei Zhang.
Thank you.
Okay. If you are talking about very high speed, the question is no. Okay, because the currently the APs have a relatively weak CPU, which are not catered for doing any computation.
Yeah. So
In order to implement that, for example, in the case of the smart lamppost, we're actually engaging in the project with the Hong Kong government for that. We actually have the luxury of using a computer inside the lamppost to do the computation. So it really depends on the applications. I mean, for different applications, there are different level of difficulties.
yeah, because network coding has been proposed for almost 10 or more years, but it's very difficult to deploy in the commercial networks. So if we can't resolve this problem, and it's still very hard to see in the practical networks. And since you have mentioned IoT and 5G, so do you envision some difference or some benefits in these two networks that can make it easier for the network coding easier to be deployed?
That's a very good question. In fact, one of the obstacles for implementing network coding is complexity. And you can think of VS Code as being an efficient implementation of random linear network coding. It is, in fact, a railless code which combines the nice features of random linear network coding and also founding code. Because it is the autocode is a generalization of founding code, so it inherits the efficiency of founding code as well.
Okay.
Can you? There's more questions. I have questions, and actually, what you're raising is a very, very valid point. And we're going to have a draft on implementation issues for network coding. And I think if you want to participate, it's great. But we're not going to close this thing here.
Okay. I will read the draft and to see. I think there are possibility. And thank you. I will ping you when I arrive in Shenzhen. I think it's very close to your university.
Okay, good. Thanks very much.
If you want to continue the discussion, I encourage you to continue it on the list, because some of your issues about network coding not being implemented in real networks, I think you're wrong. And I think other people on the list could actually reply to that.
Okay, I'm interested in that. My pleasure.
Okay, so reply to the list. I have two things, one without my chair hat and the second one with my chair hat. So first one without my chair hat, Raymond, have you thought about looking at what people are doing in information-centric networking for multi-hop communications?
Well, actually, I have listened to one or two talks on that, but I have not quite looked into this yet.
Because I think the combination of both could be very, very powerful. The other one is with my chair hat. Do you intend to write a draft on this?
We're thinking about this. We may do so. We will decide to do so in the next 2 or 3 months.
Okay, well, it would be welcome. And again, for everybody, I think this is a good discussion, and we need more of these, different types of coding approaches and everything. So thank you very much, Raymond.
Thank you very much.
Okay. So it's my turn. So I'm Vincent. With Marie-José, we had the feeling that it was the right timing to have some discussion on, FEC codes, on signaling, on protocols, but more from a practical perspective, what to do in this group, how to make those items move forward perhaps more easily. So I have just a few slides, and then we can discuss about it. Next. So as I said, we have a bunch of internet drafts that are related to these topics. We have the Tetris draft, which is very detailed on some aspects, which proposes a full solution that includes protocol aspects, that includes coding aspects, that includes signaling aspects, with also a specification of sliding window FEC codes. that's one thing. We also have work on RLNC with, well, that's just the first draft, so it's obvious that we cannot have all the details we may want to have. But this document focuses on a bunch of two potential codes for doing network coding. It focuses also with a lot of details on header signaling, header format. So that's another perspective. So it's very detailed on some parts and very more evasive on some other parts. Next. And we also have this work that I've done with colleagues on RLC for fake frame. So this document has passed working group last call, or should have passed working group last call. We'll see that today afternoon. And we got some feedback, including from the group. This is a full specification, but in a different context. And then we have this new work on RLC fake scheme for quick that we'll talk about later on during this meeting, which leverages on the first one. We're using all the code specification, all the code internals, but adding some topics specific to quick signaling, quick header, quick techniques. And we also have this potential BATS internet draft. So the question we have with Marie-José is how to make this easier, how to move forward more easily. That's the question we would like to ask the group. Obviously, there is always this divide and conquer technique that makes it easier to move forward. So here, if we look at what has been done so far, we had some work on code specification, we had some work on more signaling aspects, and we had work on protocols. And which something that could be reasonable would be to separate those things in different parts, maybe in the same document or in other documents, but keeping them separate, more or less. Focusing on one and trying to do as far as we can on this topic, and then doing the same for the other one. Next. And from this point of view, the FSC scheme is a good approach. So FSC scheme, if you are not fully aware of what it is at the same time a code specification with all the internal details of this code. The PRNG, for instance, we'll talk about it later on, or all the aspects, all the technical aspects that make it possible to implement this using this document in a fully compatible way. Having interoperability is guaranteed if the fake scheme is well defined. So there is at the same time this code specification, but also signaling aspects. So it explains how to use this code in the context of a given protocol. And what I would like to say here is that maybe this is not exactly what we need. Maybe we should do things a little bit different in terms of signaling. So instead of trying to explain and detail how we can use this fake code in a given protocol, we may do things a bit different. We may explain how to use this fake code in general, but not specifically for a given protocol. That's the illustration at the bottom of the slide illustrates this. So on the left, we have classically the format header. That's the kind of thing that we found so far in FSC schemes. So the proposal would be to leave that aside, and instead of that, trying to specify what the code itself needs. So in case of RLC, we need to specify what is the composition of this coding window. And if there is no gap in this coding window in source symbols, then we can just say, okay, it starts at this source symbol, which can be identified in several different ways, either through an ESI, an identifier, or through an offset, as we'll see later on with Quick. And then the number of symbols. We also need a few other parameters in that case. So that's the general idea. You have a question?
So Dave Oren, I'd like you to talk a little bit about what when you use the word signaling, that means a lot of different things to a lot of different people.
Yeah.
And for example, in the real RTC world, they kind of separate the setup style signaling, which allows you to sort of like instantiate enough state to get going, versus some people call it in-band. I don't like that word, but the metadata associated with the actual code that tends to be part of what's called a payload format.
Yeah.
Right. And when you talk about signaling, those things could conceivably get confounded.
Yeah. You're right. You're right. We'll do the effort to keep them separate and be more specific. In this case, signaling for me was either one or the other, so it was a little bit ambiguous. So it's clear that we need to synchronize encoder and decoder for sure, and re-encoder as well. So this is part of signaling. What I mentioned on the top, on the bottom right of this slide is more the metadata that are actually needed, rather than focusing on the formats that are on the left. So that's the idea. Next. So we mentioned before that it would be good to have a universal signaling and header format. All things considered, I don't really think it's appropriate and feasible, but we can probably, and this is my message, we can probably have some universal description of what is needed by this code. As I did before, as I mentioned before, not focusing on formats, headers itself, but on what is required in terms of metadata for this code to work in general. And then it's just a matter of instantiating this in a given protocol later on. And that's a very quick and easy document to write. So probably that's a good way to move forward. That's something that we can try at least. So that was the first point. The second point is interflow coding. So there are use cases for that. We've seen in the past. We will. There is also a desire to go into this direction with RLNC. That's great. I have no objection for that. It just raises interesting questions, interesting problems that we need to investigate. So that's also something that we could adopt as a working group, research group topic of interest, and maybe have it in a document with RLNC in a separate document. I don't know, no matter. It's not essential. Third item, parameter derivation. That's things that we try to do, as far as I'm concerned, in the FEC for fake frame, in the RLC for fake frame document. So there is a full section on this topic. So the idea is, how can we initialize for instance, the coding window, the maximum linear size that we keep at the receiver, all those parameters that are essential for this code to work. And it's essential to have this kind of technique when we are dealing with, in particular, real-time flows, because the coding window size, the maximum linear size of the receiver, all those parameters are key for keeping in line with the real-time constraints that we may have for a given flow. So this is also a topic that I would like to have to be discussed in this group, and next. And finally, yes, there is always this idea of protocol, something that could be more generic than what was done for Tetris. So can we step back and try to design something, to design a generic protocol? That's also a topic that we would like to see be discussed and developed in this group. And maybe there are other topics as well that we don't have in mind today, that I forgot, I don't know. So I don't know if you have ideas. We can also continue this discussion list. If you have comments, yes.
So Kerim Fouli from Codon. So I don't know when is a good time to give a small status update on the Janus Haider draft, as I'm going to give it now. If you want me to give it later also, it's fine.
You're on the mic, so let's do that.
So I mean, I haven't talked with all of the authors, but I think we have a pretty good idea what we want to do. I wanted to thank you very much for your comments, both. I mean, chairs gave great comments, and I think it made us actually realize that there is a lot of rescoping to be done on the two first sections. And I wanted to clarify, so I'm not going to go through all the questions yet. I need to talk to the other authors and come back, especially the technical ones, but the general question of the scope on the Haider draft is important, and I might give a few notions today. So really the main point is that it's actually a very narrow draft definition. We're not trying to be wide. So there are three sections in the draft. The third section really has what amounts to really a payload definition, as Dave said, or maybe something more of a data format definition. It doesn't have any algorithms in it or anything, any protocol aspect. Everything you have in the two first sections is really background information and presentation of the very few fields that are defined in the payload definition, which is the symbol format, really. So we didn't want to make it wide, and I think there is a misunderstanding there, specifically on this point on the inter-session. We agree. I mean, there are complications in inter-session when you implement it. We still think that format will apply to most of the applications that you have. So the thinking here is to take a step back and to say all of these applications that are using network coding, specifically random linear network coding, what do they have in common? And really what they have in common is a format, and everything else can be designed differently by different people. So we focused on the format. So it's a very narrow format, and that's the point I have to say, and I'm happy to discuss that.
Yeah, okay, let's discuss that anyway.
Okay.
I would like to have a clear idea of the focus in somewhere in this document, as I said on the list. And
Agreed.
Yeah, having background is fine. Having a section on the focus target use case, not use case, but what the key aspects you want to address, and then.
Well, I agree with you. What is missing really was a scoping part in the introduction, which says here's what we're doing in part 1, part 2, and this is part 3. Part 3 is really what we present, which is just a format, a few, and that's as reusable as possible in the different.
I'm not sure it is as reusable as that, but we will discuss this.
But that's exactly what we need as feedback. So
we'll discuss this. Okay.
Thank you very much.
Anyway.
Just I think also, Karim, I think a lot of the times you guys send us messages. I think it would be cool if you were also copying the list, because a lot of the questions that have been raised, actually other members of the list could also contribute. So I would encourage you to copy everybody.
Okay.
It's actually the opposite. Most of the time people say stop copying everybody, but I think in this case it's the opposite. Please copy more people.
Point taken. Okay. Thanks.
Thank you.
Brandon Williams, Akamai. I think the question of evaluating whether or not a common framing for the coded packets, et cetera, whether or not that's feasible is a valuable area of exploration for the group, unless people are, unless everybody is already at consensus on the point that you make that it probably isn't feasible, then it's worth evaluation. And I think the way that you frame it of looking at sort of what are the requirements for these different codes and trying to form some sort of basis that spans the variety of codes that people are looking at makes a lot of sense as an approach to that evaluation. I think, to Dave's point, Dave talked about two different, aspects of signaling, both the kind of session establishment as well as the what he didn't want to refer to as in-band. And the session establishment part is also, I think, a valuable area of exploration for the research group, whether it's actually meaningful to establish some sort of session establishment protocol that would allow for some kind of coding flexibility between the two endpoints involved in the session is, I think, meaningful. I'm unconvinced based on the way that I've seen this stuff getting implemented, whether or not anybody would actually be in a position to use that session establishment protocol. But I think it's interesting to ask the question and evaluate whether or not anybody would actually implement it and be prepared to sort of negotiate aspects of the session.
Yeah.
And the third thing I was going to mention, and this is a comment that I almost made during the BATS discussion, but it's more appropriate here. I think when we see the presentations about the individual codes and the benefits that they provide and how they're applicable, et cetera, the presentations tend to be different enough in the way that they present the cost value analysis for the code that it makes it very difficult to evaluate multiple different codes for a use case, because the way the operational parameters and like the overhead, for example, is presented tends to be different enough that we just don't have a field for comparison. And I would be interested in seeing the research group maybe put a little bit of focus in there and see whether we can come up with a common framework within which to evaluate individual codes for specific purposes.
Yeah, that's a good idea. We already mentioned this, but yes, I forgot to have it in the list. Yes,
Cool.
It's clearly on
Great.
the list. Yeah. Concerning the negotiation of parameters, as far as I know, well, the examples I have in mind concerning FakeFrame, RMT, and now Quick, it's very basic. It's just a matter of sharing 1-2 values that are required to synchronize encoder and decoder, and that's all. It's more. I propose to use this, and I share this information to everybody. It's more this way. It works this way. And what we have in mind for Quick is also using this philosophy. We'll see if it's sufficient or not. It's not really a negotiation. It's negotiation. The negotiation aspect can be, okay, I support this and this code. What do you should? You send this information to the remote side, and the remote side says, okay, we will use this one. It's more or less this way it works. But do we need something more complex, more flexible to really negotiate? I don't know. But parameter derivation is something extremely important that could also be part somewhere into this discussion. That's another point, maybe.
So I think this is another thing that needs to get disentangled, which is the setup can be done via negotiation, or it can be done simply by stating what the receiver is capable of.
Yeah.
And negotiation protocols are way more complicated than just receiver-based capability statement. So again, I'd be cautious about using the word negotiation when it may not be needed.
Yes, good point. Once again.
Okay, so I will do the bad person and cut the discussion. I saw that there's a few more people in the room. I don't know where the blue sheets are, but maybe people who haven't signed, please do. C'est encore toi?
Me once again. So let's continue with this discussion on this generic API for sliding window FCC codes. This is something that we initiated 6 months ago. The third time I introduced this. We made a lot of progress, in fact, which means that we are moving forward, and we now have not a strong proposal, but at least a proposal. So just to remind you, this is what we are considering here is this the part of the figure is not visible. I should not have used a light gray. So what we are considering here is just the codec API. That is to say, the API for the very low-level codec, and not an API for the FEC scheme itself. So the FEC scheme is much broader than this low-level codec, and this FEC scheme is in itself included in a much broader piece of software, which is the application or transport protocol or whatever. So we are considering this, and the idea is that this codec may be reused in several different FSC schemes. So that's a component, a building block that will be instantiated maybe several times in the given environment. So what is in scope of this API? Well, we have 5 items: session management, well, codec initialization and session management, which concerns the encoder, the re-encoder, and the decoder. We also have this management of coding window. We also have the management of coding coefficients. So initializing them, giving them to the codec, or asking the codec to generate them by itself, because there is an algorithm for doing that. Okay, so that's a feature that will be both at the encoder, re-encoder, and decoder. And then we have techniques for doing to ask the codec to build repair symbols and at the sender, and we also have techniques to ask the codec to decode with what has been received at the receiver. So that's the items that will be in scope of this API. And many additional things that are very important in practice won't be covered by this API because this is supposed to be done within the application, within the other part of the FEX scheme. Okay. Perfect. Okay, and this is the case, for instance, of this ADU to source symbols mapping, which is an essential key feature, which is what this mapping is meant to map what we receive from the application or from the network if you are a re-encoding node, and what you will produce, source symbols that are required by the codec itself. So this mapping is not part of this API. So that's the same for transmission, reception of packets, signaling. All those aspects are not covered by this API. Next. See? So the goal of this work is to be compatible with sliding window codes only. We are not considering block codes because they are working in a different way, and we felt that it was not possible to have a satisfying API that would cover both. But within sliding window codes, we want to be compatible with any code that would work this way. So RLC, RLNC, VATS, all those codes we should be able to use this API for all those codes. And I want to make it clear, this API must be compatible with both end-to-end use cases, situations where you have only one encoder, one decoder, but also in situations where you have this re-encoding capability. So we want to have an API for all those features. Next. So the API is structured in 5 different sections. The first one is for the general definitions. I will just mention the FEC code point because this is something that is important. Then the second section is for .2 is about coding window management. The next one is about coding coefficients management, and then encoder functions, those that are specific to the encoding side or re-encoding side. I forgot to mention this in the slide. And then we finish with the decoder-specific functions. So I will go through some of them rapidly. I don't want to bother you too much. It's a bit technical, but there are interesting aspects, I think. Next. Okay, so this notion of FEC code points can be useful and important. The idea is to have an identifier of a codec identifier that is used only locally. It won't be exchanged over the network. And it's very important because through this FEC code point, you will point to a given codec in what is available. Maybe you have more than one. It will include also, it will determine also some key parameters like the finite field. If you have multiple codecs with specialized with different fields, by using this FEC code point, you can point to one particular codec. Sorry, it will also point to internal techniques like the way the coding coefficients are managed. So you can design a codec that assumes that those coding coefficients are provided by the application, and at the same time you may have also a codec that includes a generator function that will generate those coding coefficients. So we can distinguish between them using this FEC code point. So at the bottom, just to stress this point, you can have the same FEC code implemented in 2 different codecs with, for instance, different optimization levels, and you will have in that case 2 code points, one for each of them. So that's the idea. That's used only locally, and that's an example of this list. You may have additional ones. This is not sent to the remote side. Only the FEC encoding ID will be sent to the remote side because the FEC encoding ID identifies a FEC scheme. Here, this is just manage an identifier to do that locally within the an application. Yes.
So Dave Moran, Network Systems Research and Design. This is not what the crypto folks did with Cipher Suites. I don't know whether this is the right thing to do or the approach they took is the right thing to do. The my understanding is the reason they went in the direction they went is that when you have all these degrees of freedom in describing the interface between the upper layer and the codec, you get a combinatoric explosion of options.
Yeah.
And it's very difficult to figure out whether two things will work together or to do any of the kind of certification that it's actually working the way you want. So the guys who did Cipher Suites, they basically packaged up a set of all these different parameters and, you know, and gave it one name, and you had to register that as like a package.
Yeah, yeah. That's the goal of the FX scheme. The FX scheme will package everything to a single stuff,
right,
with a given name, which is the FX encoding ID, which is an identifier.
And I get the feeling that this is, that for the API, this is not the direction you're going.
Yes,
so,
API,
and it's maybe the right way to do it, but I just thought I'd raise the question of whether we're stepping into a tar pit.
Yeah, but if we consider the three examples we already have for E4, RLC, RLNC, BATS, I'm sure we need enough flexibility to address the specificities of each of them. And I still think it is required to have enough flexibility in terms of API to be able to address all those special cases. But we will see. Okay, so then I have the coding window management functions. Oh, well, the idea is that it works differently at a sender, at a receiver. At a sender, this encoding window is managed progressively. You add more source symbols as they arrive from the application, and since the coding window has a maximum size, when this coding window moves to the left, to the right, when the coding window moves to the right, you have to remove the old symbols. So there is a mechanism for doing that automatically, and the application is aware thanks to a callback. Then you have this the similar functions for the coding coefficient management. The idea is that you have basically two possibilities. Either the application provides the coding coefficients, because, for instance, this is a reckoning point, so the application knows what to do, what coefficients to use. So that's one possibility, and you have a set coding coefficient type function for doing that. Or you may ask the codec to generate the coding coefficients for you, because this FX scheme, the associated FX scheme, comes with a coding coefficient generation function. So it's just a matter of asking the codec to generate them through a seed. Usually there is a seed for doing that. So you provide the seeds. This is the generate coding coefficient function with the key, which is the seed for the PRNG. And you leave the codec generator of them. You can retrieve them through a get coding coefficient tab function if you need it. But it's not necessarily the case. Next. And then once your coding window is ready, once your coding coefficients are ready, you can ask to generate to build a new repair symbol. So you have a function for doing that. So that's basically the way it works at the encoding side. Maybe a bit differently at the re-encoding side. We need to figure it more out. But okay, next. Then for the decoder, it depends on whether you receive a repair symbol or source symbol. If it is a source symbol, then it's pretty easy. You just have to decode, ask the decoder to decode with what has been received. So there is a function for doing that. Decode with new source symbol. You provide the buffer, the size, and that's all. And in the case that you receive a new repair symbol, you just have to inform the codec what is the coding window that has been used to generate this repair symbol, what are the coding coefficients, either by providing them or by asking the codec to generate those coefficients thanks to a key that has been carried in the packet header, and then you call the decode with new repair symbol, and that's it. So maybe decode with new repair symbol will decode something actually, or not. It depends on the linear systems. One very important feature is the presence of callbacks. So callbacks are functions that are implemented within the application that are called each time some event happens. So this event can be, for instance, with an encoder, the fact that a source symbol has been removed from the coding window. So as I said, the coding window has a maximum size most of the time. So if it shifts on the right, then maybe, most probably, there is an old source symbol that has been removed. So by this way, by this callback, you can inform the application that this source symbol has been removed from the coding window, and then the application is free to do whatever is needed, freeing the buffer, things like that. Next. And you have a few more callbacks for the decoder. I'm not completely sure this is the final list. We will see later on. But okay, you have a callback typically each time a source symbol has been decoded. So that's very important. And source symbol, yeah, that's the main one. I skip the details. So now what we need to do is to challenge this API with a real implementation. That's probably the next big thing to do for this API. We've discussed with co-authors, and Cedric pointed to me that, okay, maybe something was missing, was done in the wrong way in this API, so we will fix this. I don't go into details once again. I skip the ESI, and then, yes, the final point is that I'm not sure this API is great when you have hardware codecs. That's something that was already mentioned, raised by Dave last time. That's something important, but honestly speaking, I don't know how to do that, given the way it works. So we need to think about it more again. With this approach, since we move symbols independently from one another, it's maybe not the best solution, because the DMA will take time to set up, and all this, this latency can impact performance, for instance. So that's the situation. I don't know if there are comments, questions, no? Otherwise, I will continue with next presentation. Yeah. Okay, I wanted to give you a quick feedback on what lessons we learned from the specification of RLC fake scheme for fake frame. And I will focus just on one aspect, which is the PRNG. This is something I already sent on the list, but I would like to give you more information. Next. So we have been using this very classic Park-Miller linear congruential PRNG for years. It was already in RFC 5170 LDPC specification. So this is very basic. We have this formula. So it works this way. You have a seed. So once you have seeded the sequence, then if you need one more pseudo-random number, it's just a matter of computing this formula 8 times the previous PRNG number, modulo m, where A and M are constants that has been chosen by the designers, by Park and Miller. A equals 16,807. I don't know what has been chosen, but it's the right value to use, and M is this value. So it's pretty easy to do, and we had no problem with LDPC. But in fact, the way it was used in LDPC was quite different from what we need in RLC. In LDPC, we seed this PRNG only once, and then we produce a very large number of pseudo-random numbers from this seed. And we also scale, I forgot to mention this, but it's important. The result of this PRNG is between 0 and maximum value. And in practice, we need to scale this between 0 and a smaller value. So this is the motivation for this max V. So we have this scaling. And in case of LDPC, this max V value is quite large. It's several thousands, because this is a large block and there is a dependency with the block size. Next. Okay. But with RLC, it's totally different. It's totally different because we need to produce a limited number of random, pseudo-random values for a given seed. So typically this is meant to determine to compute the coding coefficients. So if we have a coding window of size 20, then we need to produce 20 pseudo-random numbers using this PRNG. And the problem is that most probably if the application generates two repair symbols for the same coding window, this application will use some seed, S, and then for the next repair symbol, it will use seed plus 1, S plus 1. And if you come back to the previous slide, you will see that the difference between the two produced values will be only 8 times S or 8 times S plus 1. And this difference is not that large. So, next. Yet not. Perfect. And so you can do a very easy test. You test with seed 1, 2, 3, 4, etc. And you see what you get as a result when you scale the result between 0 and 255, because we are working on finite field 2 to the power 8, so we need a value between 0 and 255. And you see that the first value is always 0 for a certain time, then always 1, then always 2, then always 3, etc., etc. So that's typically a very bad behavior for us, because it means that the two repair symbols will use exactly the same coefficient for the first source symbol. And it's bad. It does not bring you enough diversity. It's totally useless to send two repair in that case concerning the first symbol. And there are also bad properties in terms of it's not a good coding, it's not a good PRNG for our usage. So we searched next, and we decided to use something else, especially as sometimes we need to scale between 0 and 15 and not 0 and 255. So the situation is even worse in that case. And we finally came with this TinyMT32 PRNG, which is a well-known and now, yes, it's one of the most used, I think, PRNG currently. It is a variant, a compact variant of Mersenne Twister PRNG, which have provable quality. And the good side also is that it comes with a reference C implementation that is included in our documents. And we solved all problems with this. Well, we think we solved all problems with this PRNG. So the question is it fast or not? That's next. The answer to this question is yes, it's pretty fast. So the initialization is a bit longer, but otherwise, when you just need to produce random values, it's quite fast. In this environment, in the Cortex A15 embedded board, we are almost 2 times faster than the previous one, linear congruential PRNG. So this is not a problem. We also did tests on the MacBook Pro, but then it was a little bit the opposite. It was not exactly 2 times slower, but almost. We don't try to investigate much more this difference. And in fact, it doesn't matter so much. The idea is that in terms of pseudo-random number generator speed, it's fast enough for our usage. Next. One specificity with this TinyMT32 PRNG, we need to specify 3 key values, 3 magic values. There is a complex program for determining what values you need to provide. You have millions of possible triples for initializing this. We chose one of them, which is one that was mentioned in the paper and also generated in the big list of values. It was the first one. So we decided to choose this one. So it's very important to keep those values, or we may choose something else, but those values are working. And finally, to finish, when this RLC for fake frame document will be published as RFC, we will have this full full specification of this TNMT42 PRNG that could be reused in other documents. And I think that having a good PRNG is essential for this research group, for documents. So you may use something else, but keep in mind that PRNG is not trivial. I'm not a mathematician. I don't try to change anything in the PRNG myself. I'm using them in the way the authors think is the most appropriate. And we should stay with this approach, because at some point of time, we imagine removing the first sequence, the first pseudo-random number, skipping the first one or the first 10 ones and using the other ones with the Park Miller. It was not a good approach. It was not a good idea. So stick with this. It's a good approach. I think it makes sense. It's reasonably fast. It has provable quality. So that's the point. That's the feedback I have. Questions? No? The internal state of this TNMT42 is quite large. So this is not something you can send on the network. It is composed of 7 32 bits words. So if you need to send something on the wire to the decoder, then you need to provide a seed, but not the internal state of the PNG. Okay, I'm done.
Questions, comments? Kerim, I have a question for you. Have you guys experienced anything like that in your implementations?
So Kerim Fulikodon, that actually is a good question. I will forward it maybe to Yanis, who deals more with the implementations.
It's online, but yeah, you can send it to Yanis. But anyway, I think it's a really interesting find.
Yeah, good point. I'll do that. Thanks.
Okay.
Yeah. Trivial. Now, when I look back at what we did before, it was obvious that there would be problems with the Park Miller PRNG. We just omitted to think about it. And, we made a big mistake, but it's fixed now.
So just to connect to a gentleman from Akamai's point, I think it's really a good idea also to look at the impact. I mean, this is a general point, of course, to look at the impact of these choices on what we decide to benchmark as the performance of these codes. So in this case, you mentioned the speed, which is great, but then if we have a common framework for,
we need to definitely also add an item on benchmarking framework and methodology.
Exactly. Yeah. Apart from the speed, actually, maybe there are other things we can discuss. Sure.
Okay, so the next one, there's no presentation. It's actually a question to the group. We had started at the interim meeting last September. We had started looking at the impact of network coding on congestion control. Emmanuel came up with a presentation that was nice. I think it was in Singapore, and we kind of dropped it. We now pushed it. I think I'm going to talk about it at the end in the milestone. I think it's been pushed further out. However, I still think it's a very important aspect to look at. The gentleman who was talking about the issues of implementation of network coding, this is actually an issue that keeps coming back, how network coding influences or is influenced by the performance of TCP in particular. I wanted to raise it today because I knew that we had online and in the room some of the people hadn't been involved. I think it's important. I think it's important that we continue, but I don't know. I would like to know if anybody's ready to contribute, if the work that's been done, or if Emmanuel, for example, if you're ready to present your version, as some kind of a draft in the group, which could be one solution, or if Akamai, who had been interested at the beginning, would be interested to continue this. It's more of an open thing because it's part of our milestones, and I thought I wanted to raise it. Emmanuel, you had a question?
Yes, hello Marie-José, hello Vincent, hello Hall. Just to complete, I did some attempt on the mailing list to try to federate people around the network congestion draft, but I didn't get any feedback. So,
well, I think it's worth reopening it and see if there is now maybe more interest. Again, because I think we are moving towards like real world implementations, but I think it's worth it. Maybe at least send a message and see if other people respond.
okay, I can do that.
And again, I think because I'm going to start, and I think this is ahead for the later, but I was also on the line to start a draft on issues for implementation, and if I could refer to yours, I wouldn't have to write that part. I could say, issues for implementation, network coding, C, draft X. So anyway, it was just to raise it, and also Brandon, if you want to raise it back in Akamai, it would be great. Thank you, guys.
Okay, thank you, Marie-José.
Okay, thank you. So that's the end for the first part. And now we can continue with quick, coding for quick. So Jan.
Assistant.
You sent something. You sent the new version.
No, I was okay. Sorry.
So the old slides are yesterday.
Yeah.
Yeah, the ones that we talked about yesterday.
Okay.
Yeah. Yep. So this is an update on coding for Quick. First, I want to thank Marie-José and Vincent for all of their help in this. Obviously, I know a lot about Quick. I know very little about coding, so it's kind of a one of those things where we're trying to get people together who are experts in both fields and produce a combined solution that works. Next slide. Oh, or do you have it? Okay. Yeah, so this is mostly an overview of kind of what are in the two IDs. There's a general considerations document that introduces things like this new repair frame and talks about how you might extend Quick and use the new Quick extension mechanisms that are now in the most recent drafts. And then there's another document about how you use RLC as kind of an example code in this application space. And certainly there could be more drafts for different algorithms, but obviously Vincent's very familiar with RLC, and so and we believe the application performance is likely to be quite good, so it's a good starting place. So at least at this point, the main principles are that the protection is at the stream level. This is mostly done at the moment for simplicity. We can certainly imagine cases when you would want to do cross-stream protection, but I think the framing and other things increase in complexity quite a bit, and we can kind of go into why that might be true later. You can negotiate FEC. We'll talk a little bit about the trade-offs there. There's a kind of a frame data to source symbol mapping that is provided by this repair frame that we've added. And then all the data is transmitted in stream frames initially, and then the repair is, of course, transmitted in repair frames. So at some point, we would like to do protection across multiple streams. And we can kind of, if there's any discussion and suggestions on that and how we might make that easy, that would be appreciated a little bit later in the slides. Next slide. Yeah, so we're protecting a single stream. We are not leveraging the quick packet number field, which originally we talked about doing. And actually, the original quick forward error correction scheme did actually use the packet number field, and it did everything on a packet granularity. The nice part is that the stream is typically the thing you actually want to deliver. That's the thing that contains application data in Quick. The other frames in Quick are, acknowledgements and, maybe resets and like various other kind of metadata and control frames. But they're not actually the application data, and the application data is what's latency sensitive. So as I said before, it's possible to protect 2 or more streams in Quick, but it adds quite a bit of complexity, and it's not really clear whether the extra complexity is worthwhile, both in implementation and also making sure that the structure of them is complementary, and you're not protecting like an audio stream with, say like a large file download and combining those two. I mean, you have to start getting a little bit more intelligent about how you're going to do the coding. Next slide. So negotiation. So Quick has something called transport parameters. These are just basically a list of key value pairs that are sent in the handshake. The client sends theirs, the server sends theirs back. And in the case of this negotiation, it's just a matter of the client says, I can use all of these things. The server says, I can use all of these things. And the intersection set is sort of like what you can agree on. So because it's a fairly open-ended format, it's possible to put parameters and other like scheme-specific information in the header, in the kind of value portion of the header. So you can say like, have a reserved header for I want to negotiate, a forward error correction scheme, and have the metadata within it be somewhat rich and complex depending on the scheme. So obviously, like you have to both agree on something, but besides that, it provides quite a bit of flexibility. There's a question of whether we want to be able to negotiate two at once. In theory, that's certainly possible, but it adds some complexity later on because then we have to indicate which scheme we're using at which point in time. The RLC configuration information, there's an encoding ID, which identifies the scheme with an IANA registry. And we have the symbol size, which is at least initially fixed over the course of the connection. Next slide. It's also worth noting we now have an IANA registry, or going to have an IANA registry for all of the Quick extensions. So the definition of the frame that we're going to be talking about, as well as the use of the transport parameters, goes in an IANA registry as well. So yes. So is it worth selecting several schemes at once? They may have different trade-offs, real-time content versus like bulk content, but there's a lot of extra complexity because then you have to identify which scheme you're using every single time you use it, or you have to set up a stream and say, like, when I create this stream, I'm going to use this type of repair symbol versus that type.
All right, Dave Oran, super stupid question. Are streams unidirectional or bidirectional?
We have both. It's even worse.
So there's another degree of freedom here, which we should put in the open questions, which is, should you use a different FEC scheme for different directions? Because sometimes...
Sure, certainly. Or even if you want to get more complex, I guess there's unidirectional, bidirectional, and should you use a different scheme from client to server than server to client?
Yeah, I mean, I agree about the complexity, but if you want to just, capture all the design, the shape of the whole design space, you probably should just at least mention it.
Yeah.
And actually, I can just think of a use case that works for this. So actually, it's a good comment.
Yeah.
Where I would use a different scheme from the source to destination than from the destinations back to the source. So yeah, it's a good question.
It is a good point. Yeah, that's actually probably one of the more motivating ideas of negotiating different ones would be if you wanted, as you said, like it to be asymmetric because the link characteristics.
But, you could think of something where you really have to have the request sent, but you can maybe wait for the reply.
Yep.
So and then you would use two schemes because you may not need to have the same requirements. So I think, thank you, Dave. It's a great comment.
Good point. Thank you. Next slide. So we map from frame data to the source symbols. So the application data is a variable size. So this is all kind of in order sequence of bytes. It arrives in multiple stream frames. And then the symbols kind of map onto subsegments of that stream and protect different portions of the stream. And so we're using the stream offsets as the kind of like key into what we're actually trying to protect. So, next slide. So on the choice of the symbol size, you can, in theory, use anything. Longer symbols are kind of fit into frames better, easier to manage. They have less overhead because you don't have multiple frame overheads from each one. But as Vincent points out, the larger the symbol, the more it covers and the more you might hit a boundary that you can't actually use and recover. And so that's also unfortunate. So we need to kind of find a balance, but the current thinking is that the symbols should be smaller than a packet because the overhead of adding symbols that are larger than a packet means you start having to be able to piece together symbols. And then if you lose either half of the symbol, the whole thing's useless. It's kind of like IP fragmentation. It's just a whole world of complexity without much benefit. So at least that we're fairly sure that that kind of constraint is a reasonable one, but the rest of it's still fairly open. Next slide. There's no need for an encoding symbol ID. I'm less familiar with this subject, but my understanding is that essentially we're using the stream offset instead of an encoding symbol ID. Is that correct?
Yeah.
And so we're basically using a built-in quick mechanism, the stream offset and ID instead. And you'll see that, I believe, in the next slide when we talk about what the frame layout actually looks like for the repair frame. So.
I can add something. Historically speaking, in RMT, in fake frame, we always consider encoding symbol IDs that identify either source symbol or repair symbol. In this case, in case of quick, we can get rid of this identifier and replace it with this offset within the source flow, which makes things much simpler, in fact, more effective. So that's a good point and a good feature of quick that we will reuse in this context.
Yeah, so one nice part about this is that we're still using the existing stream frames. They're built into Quick. So those are totally backward compatible. And of course, we can kind of transmit the original data, and if all of it arrives and the peer realizes that all of it arrived, then they can just discard all the repair symbols fairly easily. And it's quite easy on the receiver side. So the repair data is in a dedicated extension frame. And the idea is that we're going to reuse the repair frame for all of the different schemes. So this is going to be kind of like the common encapsulation. It's going to have some common features that we're going to see, like the stream ID that it's trying to repair and the offset, and then and a variety of things that I think are like kind of pulled in from the FEC frame design. Kind of a common, it's like a hybrid, it seems, of the FEC frame design and the quick stream frame design. Next slide. Yeah, so this is the wire format layout. The stream ID is a variable length integer, which is the standard kind of quick currency of how we encode stream IDs. The next is an offset in the stream. So that's also kind of a standard like quick stream ID or quick stream frame sort of item. And the next one, of course, is the length of the, not the stream data, it's actually the repair data that's in the payload below. And then you have the PRNG seed and the, I guess the RLC density param. So.
Brandon Williams, Akamai. One question about the format. I'm not familiar enough, or I don't have the FEC frame format that we've been looking at off the top of my head. Curious about how similar in format this is to the FEC frame stuff that Vincent has been working on.
So
in case of FEC frame, you will have those 42 bits. It's not, in case of FEC frame, an offset, but it is the encoding symbol ID, an identifier of the first source symbol in the decoding window. And then you have the full 32-bit word that provides the key, the DT, the NSS. It's exactly the same. So both words are the same. The rest is specific to quick.
Fairly similar.
Yeah, fairly similar. In that case, it was possible.
Yeah, that's why I was describing it's a little bit of a merge of the FEC frame and like the quick stream frame. Yeah. Next slide. So one issue is you may actually like have a last symbol that you want to send, but you don't have enough data to fill up the window, and so you're kind of stuck there, like waiting to send it, and then you just never end up sending it because you never, you go into quiescence for too long of a period of time. I think probably the easiest solution to this is just adding a timer. In Quick, we have some experiments with adding a proactive timer after about a quarter of an RTT of just sending out kind of like whatever is remaining. And it seems to, in practice, like work pretty well. So I think this is a fairly solvable problem. I mean, obviously, like however you set this timer is a trade-off between sending it too early and like, closing out a group prematurely when there's more data coming, and waiting so long that basically the symbol is useless.
Brandon Williams. just a suggestion. You had an open question earlier in the deck related to how much value there might be in being able to apply a single FEC session to multiple streams, and I think it might be worth keeping that in the back of your head as you think about this side of things, because I think they may be fairly related. I think the greatest value in being able to apply a single session to multiple streams is probably going to be in the context of low packet rate. Like if you have a multiplicity of low packet rate streams,
Yep.
Being able to apply to multiple streams in that context will be really valuable, and you would have similar issues in that context to this. So it's probably a trade-off between, well, how costly really is how much worse will it be if I just use the other retransmit mechanism or other recovery mechanisms versus the complexity of being able to apply the single FEC session to multiple streams. But just something to think about.
Yeah, thanks. So, I think that's it. Great, thank you. And yeah, again, if you have people have thoughts on kind of effective ways to do multi-stream recovery, I think that's certainly. I think there are a variety of applications that would benefit from it, but it adds a lot of complexity. I'm not really sure exactly how you shoehorn it in without making this design quite a bit less elegant. So,
one word on next steps, Jan.
Sorry, we didn't have a slide for that. Yeah, so I think the plan is to update the document. Like the quick extension mechanism was only created very recently, so we probably need to update the document just to make sure that we're getting a little bit closer to defining that the way we're using extensions in a way that the quick working group would be happy with it. From my perspective, I think we're getting close to the point where I was thinking about this the other day. I think myself or someone else, it'd be great to have like an intern or someone else who is interested in doing kind of a research project to focus on this and try to like code this up and see how this actually works for a real application with the existing existing quick implementations. And now that there are quite a few options. I don't have a candidate for that, but certainly in my case, if we always have spots for interns at Google. If you have someone in mind who you think can actually go through the interview process unscathed, then we would appreciate a referral, and I'm happy to host them.
I can actually also say something. We were supposed to have a meeting with Christian Utema about actually doing an implementation on his. However, he had a death in the family, so he could not come to Montreal. But it is in our goal to talk to him next week or the week after, and he actually was really interested in doing a first implementation.
Yeah, I had heard that, and then I hadn't heard anything, so I didn't know why.
No, it's there's a family issue, and we were supposed to meet him on Sunday, and he canceled Friday, I think. Like it was like really last minute.
Well,
so there is at least going to be that, and maybe having another one with an intern at Google could be cool.
Yeah, no. So definitely feel free to refer people.
Which brings up the other degree of freedom here, which is how this interacts with multipath extensions to Quick. Because coding is way more helpful in multipath than it is in single path.
That's solidly on the Quick V2 plan, and there's no multipath research working group, so no one's talking about that officially yet.
So, but we have a trade-off as how quickly we move this forward to how far ahead of the curve we get in freezing something that might not interact wonderfully with multipath. Quick extensions. So I think we have to sort of like dance around that for a while.
Yeah,
so we can make a lot of progress, but not freeze something that we wish we hadn't frozen.
I would agree. I would definitely agree. I think this is going to remain kind of a ongoing work for probably a while to come until at least we have 2 or 3 implementations on real applications. I mean, from my perspective, like WebRTC is a great use case, but currently WebRTC uses a lot of little streams, and so I don't really understand exactly how to like rectify the fact that like the single source, the single stream issue. So that's something I'd like to figure out.
Thank you, Jan.
So Nicolas and Emmanuel, you're still there?
Yes.
Okay, it's your turn.
I think that would be a very short presentation, just to give a quick update on the.
We can't hear you, Nicolas.
Can you hear me now?
A little bit better, but still it's not that
Wait a minute,
great.
because last time it was too loud, so I was very cautious this time. Okay.
Is it better? Too much? Too much?
Too much.
Okay. Is it better?
That's great.
Yeah.
Okay. So that will be a very short presentation to give an update on the network coding and satellites draft. So next, please. Since the last IETF, we have had a very full review of Vincent. Thank you very much, because I think that indeed there were lots of issues on the presentations, and sometimes things that were clear to me weren't so clear. So I think my point is not to go through all the points in these slides, but this is more to give a list of what has been done, which was mostly improving the clarity and the presentation of the draft. Next, please. So since the last version, Vincent gave us other comments, so we need to assess them and submit another draft. So we plan on doing that soon, but the cutoff date was passed, so we have to work on it. But basically, we still have to work on some figures. We want to add a research challenges section before the conclusion. And also, we may want to give a couple of words on security. There are security aspects in SATCOM, but I'm not sure to what security aspects and network. What aspects in net security and network coding in SATCOM are very relevant, or I think it's more security and network coding in general. I'm not sure there are specificities for SATCOM, but we may want to propose the conclusions if there are any security issues in the use cases proposed in the draft.
Yeah, the problem is to be able to talk about security, but with a strong linkages with network coding, and this is quite complicated. We don't have a precise idea yet.
We are thinking about it, but still. And also a more the question is, what do we do with this draft? We have had some reviews, mostly from Tommaso and Vincent, but still we think the document is soon to be ready. So we don't know if it's possible to make it a working group item to move forward with it, or if there are any other plans.
Yes, thank you, Nicolas. Yeah, it's great. So my main comment was about maybe the lack of research challenges discussion in this document. So if you can improve this aspect, that would be very useful. And as far as I'm concerned, I found the document quite easy to read and interesting, and brings new. Well, I'm not familiar with this domain, and I learned something by reading it. So I think it's useful.
Good morning, Stu Card, new participant. I'd be happy to have some conversations with you about the SATCOM security issues. And one that I'll throw out there right now is satellite really facilitates reflection-based denial, well, distributed denial of service attacks through spoofing negative feedback. So that's one of the ones that can have catastrophic effects. That's fairly easy to trigger. We can talk about that and other things.
Actually, it would be great if you started a discussion on the list, because the list has a number of people from the European Space Agency. And I think, John, are you a member of our list? And so John is from Hughes. So, or what you would, yeah, so there would be, I think that could be a very good discussion on the list.
Yeah.
And while I have the mic, yes? And so I think we're obviously going to put that to the list as far as the working group item. But is there anybody in the room here who would have a problem of putting this as a working group item? Okay, so nobody does. So guys, there's a strong possibility, but we'll obviously put it on the mailing list. But that would be, I think, a very good contribution for the research group.
Thank you. Thank you. And so just a quick comment on the security. I would be very happy to have discussions on these security issues in SATCOM and the problem with denial of service attacks on other attacks. I'm not sure it is the scope of this draft because it's more on network coding and security and SATCOM. But if we can start a discussion on security and SATCOM systems in the IETF, I'd be happy to start it here. Anyway.
There are two aspects. One of them is this mandatory security consideration section, where we need to talk a little bit about security. And the other one is maybe it could be also a research item by itself. I don't know. So
we'll try to do something.
By the way, okay, so nobody is against in this room the fact that we have this as working group item, but is there anybody who volunteers to review this in the future during working group last call in the room?
John?
Okay,
and
two
John
people.
and Stu. Yay.
That's great. That's a good sign as a working group to adopt it as a working group item.
I love volunteers.
Yeah, I will do that as well.
Oh yeah,
yes, sorry. Sorry. Okay, so let's continue on the list.
Thank you.
Thank you.
Thank you. Okay, so next topic is about this joint work between our research group and ICN-RG.
Yes.
I see that Itoshi is here.
Itoshi is here.
Hello.
Would you like to just say a few words? Anyway, I had talked to Cedric about it. He was supposed to send me a few slides. He did not, but it's okay. This is another one where there's been a lot of progress. And this is another one that we were ready to put to working group item. But Hitoshi, do you want to comment on what you've done recently?
Well, Hitoshi said, I don't know which research group will have the task to decide the let's say network coding research group working draft or ICN research group's draft. I don't know which research group will take a role of that document. But in any case, the requirement for network coding for ICN or CCN is important to decide the solution, because network coding for the ICN is really one of the most important use cases. So in any case, we definitely need to have the solution. But before defining the solution, we must clarify the requirements. So I think it's now good timing to decide this document itself can become a research group draft.
Okay, we have Cedric on Meeteco. Cedric, would you like to make a comment?
I have no specific comment. I mean, I just second what Hitoshi just said. I think this draft has been iterated and maybe it could be recommended for adoption. No. Did you hear that, or does that work? Or?
Yep.
Okay.
Yeah.
And if there's any specific question, I'm happy to answer. But since she's there, he can answer directly as well.
Okay, so we have talked to the ICN chairs, and we have one here. And I think there was a proposal to submit it at both places and see where there would be a critical mass of people to review it. The idea was that there were maybe more people in the ICN group that knew about coding than people in the coding group who knew about ICN, which was one aspect. But we can see, I think it's been done before, and so we could do it that way. And Dave, as your chair hat, what do you think?
So first of all, the last thing we need is a political football. And secondly, these two groups tend to have not had a problem in the past getting along. So I think in terms of theory, it doesn't really matter. In terms of practice, I think I was the one who made the comment that it's, from a practical standpoint, better to land the document in a group that has that more of the other people show up at, and we don't have machinery to actually have an IRTF document that is shared between two RGs. If we had such a mechanism, this would be a poster child for doing that way. So I can't necessarily officially speak for the other two co-chairs, but I don't think we should obsess too much about this. And if there's energy in NWCRG to really work on this. ICNRG also has a pretty not full plate, but we have lots of stuff going on. So we're not in we need to grab this to have something to do. Right? So I'm happy either way. I might call the question with Allison just to make sure the IRTF chair is happy with how we resolve this.
Okay, thank you. Thank you, Toshi.
Thank you, Cédric.
Merci, Cédric. Bye.
Bye.
Okay, next.
So, what's next?
C'est moi. C'est moi. So what's next? So it's me again. We're early, so we have a lot of time to discuss about what's next. We're early. Okay, so let's go back to what we had at the beginning, the slides where we were talking about the milestones and everything. The slides we stopped the slides at the beginning. The initial slides we stopped and said, let's keep that for later. Okay, so we've been doing this for a while, so I looked at some of the milestones. And so there are good news and there's less good news. We would like to have and again, I hope Emmanuel is still on the call. We would like to have a new update to Tetris, and we would like to move it to a working group item. We're a coding group and we have very little coding drafts, except the one from Vincent. And the same thing for the RLNC. Kerim, you guys were the initial people for the formation of this group, and I think we still need a good draft moving to probably working group item and RFC on the on RLNC, which again started this thing. So I think we'd like to have attention from the authors.
Yeah, so definitely. I mean, the intent here is for us to I'm going to speak to the other authors, and probably I'll join.
Yeah.
And the point is to basically get new draft hopefully in the next 3 weeks.
Okay.
And
yeah.
put it
Well,
down.
for Bangkok. But what I say is that you saw the proposal. If it's too complicated to go to the whole protocol and everything, just do something that says, what is RLNC? Because we talk about it a lot in this group, and we never have a document that we can that's generated from the group that we say, people, look, this is what it's doing.
Okay, so that's a good point. I think it's a good addition. It's not the scope really specifically of this draft, but I think it's a good point. What this draft is trying to do is to basically introduce the items that are going to be used later in section 3. Basically, there is a background section, that's true, but we don't want to expand it. I mean, we could expand it, but we'll need a lot of help doing that. I mean, we are stretched.
Well, okay, so I would actually put it out on the list, because there's probably as you know, Muriel's code has been used by a ton of people. And a lot of these people are on this list. A lot of people have worked with the code. I could actually write it. There's a lot of people who know you could write it. So I think, again, I think you're not using the list to help you guys. So I think I would do that. I would say, you are adding information to the draft and you would like to get help, and that's fine.
So definitely we'll make a new
And
version.
people are aware of the IPR issues, people are aware of everything, but people can write, so that's fine.
So yeah, I mean, what I have in my list is definitely a new version of the draft, and then we can take it from there.
Okay, cool.
That's...
The Tetris people, I think, is the same comment. You guys are very advanced. There's still some things to be done. You're one of the authors, so it needs attention. So NC and Quick network coding and Quick. Ian presented. We have the initial drafts. We decided to make two. One is how to do it, and the other one is a specific code doing it. So that's cool, and we could have from there maybe others, and it's not problematic. We have, as we just said, an initial implementation that's planned. There could be others, and Ian nicely suggested sending poor people to the grinder at Google.
It's only the interview process that's bad. After that, everything's great.
Well, okay, so to have done the interview process, I can tell you at least they feed you, which is not bad. The food's great. Even for the interview, the food's great. So anyway, if you have people who are interested in free food and being grinded, send them there. So we actually just said that for the satellite, we're going to probably make it into a working group item. So this is good progress. The ICN, same thing. Common API, we did it. Okay, so, and this is one that I was supposed to do, and in the past few months I've been doing other things, and I was really sick, so I didn't really do anything. But I really want to do something for the interim and the IETF 103 on adoption challenges. And our colleague who actually asked questions, I would really, if you want to participate, you're more than welcome. I mentioned where some of the adoption challenges were, and there are many. There's technical challenges, there's implementation challenges, the availability of codecs and everything. What we're pushing to the future, excuse me, is the congestion control, like I said, but I would like to have a conversation started on the list, or we would like to have a conversation starting on the list. And the robust tunneling, I think we pushed that to way later because we don't really know what we're going to do with that. Next. So future meetings. We will be in Bangkok. What was the name of the thing? One night in Bangkok? Yeah, we're going to have one day in Bangkok. Remember, there was a huge ABBA thing about one night in Bangkok. Probably shows my age. We need to prepare possibly, I think it was a 90s thing. What? Chess, yes, one night in Bangkok. By the way, the video is fantastic. I think it's the only thing of the whole chess that is worth watching. It's one night in Bangkok. And it's from a guy from Montreal, by the way. You wrote the song. Anyway, hackathon for IETF 103. We are starting to think about it because of the API. And I think we're getting a few people excited about doing that. We know that it's a lot of work, but I think we're ready to do it. And the interim, again, it's interesting because at the ICNRG on Tuesday, they announced that we were going to have an interim meeting, which was cool. It was suggested to be on the 25th in Boston because a lot of the people of the ICNRG who are interested in coding are going to be in Boston because it's right after the ICN conference. And it could also be totally virtual. It could also be because of other issues, and also to maybe get, we did it in Boston last year. We're thinking maybe we should do it in Europe. It's not a bad time to go for people who want to go. And also there's a critical mass of network coding people in France, in Toulouse and in Ria and other places. And some people also in Germany. So we're going to ask the list. It would then be probably the 26th, so that the people who are in Boston have time to go back, including me. But we're going to put it on the list. And the reason that we want to have people always say, wait, would you like to have an interim? Well, there would be two reasons. One is, again, to make a lot of progress on these coding drafts, and to make a lot of progress preparing for the hackathon, so that we know exactly, what we want to do and everything. So that's about it. And again, Vincent and I, we seem to be taking a lot of room in this because we have a lot of work in there, but we know that everybody's contributing, and I think the group is making huge progress, and we hope that it continues. So that's it. Questions, bashing? If not, we finish early.
Just on time.
Well, just on time?
Yeah. We still have
okay.
5 minutes in the official term.
Oh, cool. Yeah, finish early. Yes, hi.
Stu, again, I'd just like to make one quick comment on the adoption barriers issue. I keep one foot part-time in academia, but I'm mostly in industry. And it's the nature of our life that everything has to be done yesterday.
Yeah.
Which means we don't have the time to dive as deeply into understanding things as all of us would like to do. 99.9% of the programmers who use TCP don't know how TCP works.
Yes.
But they think they do, and they are comfortable with it, okay?
Yeah.
So if we want a network coding-based transport to be adopted, we need to have a Big Dummies cartoon guide to network coding so they think they understand how it works and become comfortable with it. And it needs to look just like TCP to the application.
Okay. Yeah, okay, well, you make a point. The goal here is not to have a transport. We talked about it. Okay, so there's been a discussion about, do we want a network coded transport? And we've discussed this in the past extensively. And the reason that we did not do it is exactly because of what you're doing, and also because it is so easy to not use it. You can have all the new transport you want, but nobody uses it. It's useless. So the issue here is not that. Is we want the network coding and the transport to be fairly independent, or so it's not because you use TCP/X that you're not going to be able to use network coding. Those two things are different. However, the fact that you use network coding, because you're hiding the losses, then the whole TCP congestion control starts, having some free games. So the idea here is, and Emmanuel, I don't know if he's still on the call, but Emmanuel, for example, did a lot of work on how to make sure that the two things kind of work together. There's work, like if you think of people like Akamai, for example, who have fountain codes and other codes on their network, they found another way to do that without touching TCP. And the goal here, again, is not to propose a new transport. First, I think it's really hard to be accepted. And second, I always think that somebody will go back into their Linux stack and change the transport just because they don't know what this new transport's about, and I know my applications works better with that version, and I'm never going to use it. So I get your point on one thing, though, is that one problem with the implementation is also to have a good code base and a stable code base and something that people can actually use. And this is all one thing. But maybe Dave has another idea.
So I think we may have warped the discussion from, do we need documents that will get people more excited about adoption and more comfortable with adoption? And I think we just confounded it with, do we need to have a network-coded transport? And,
yeah.
So one comment I'll make that I think in support of I think what Stu is getting at here, with people coming from industries, we had this horrible experience with parity codes for real time that SMPTE got ahead of the curve, and they basically published something that people actually started deploying that didn't work.
Yeah.
Well, excuse me, it didn't work if you'd actually read the RTP specification, because they broke RTP. So you could either have their stuff running, or you could have an RTP implementation that worked. So, I think we have both problems. We actually want to get stuff out there, but we also need to know if somebody else is getting something out there around the side, and make sure that we don't have to, like, FECFrame wound up having to take a big hammer and redo everything that SMPTE did.
Yeah.
And then DVB actually was the one that went to SMPTE and say, no, and then DVB had more international power than SMPTE. So we finally sorted it all out. But it was really unfortunate this had to be sorted out 3 years after the fact.
But there's another thing I would like to add, and so maybe we can take that to the list also. Again, when our colleague earlier talked about the fact that there was no network coding that was working in real networks. We're all under NDA with I don't know how many companies who have actually done it. And maybe it would be interesting for these companies to come forward and say, this is our experience. I know sometimes there's question of competitive advantages of having these solutions in their network because it gives them an advance to be better than the others. There's all issues of, obviously, issues of IPR, issues of everything. But I think this is something we should put on the list, a discussion about who has done this in a real network and would like to come forward and talk about the issues they had. Was it in terms of development? Was it in terms of, well, we all think that the performance improved, but at what cost? So was it a hit on their time of development? Was it a hit on the time to market? No, there's all kinds of things like that. Yes, I know in industry, it's always for yesterday. So if you come with, I have this great idea, will improve performance by 25, 30%, but it will take 2 years. I'm sure nobody's going to even listen to me for a while. They will listen to me in 1.5 years plus 3 months when it's going to be due. So I think it's all issues like that I want to put in the draft, but also I would like maybe, the discussion on the list to say, this is what we think are the issues. And it's been an ongoing thing about the congestion control. It's been an ongoing thing about, the fact that we're looking at this that hackathon for the open API implementation. That has been an issue. There's just maybe others, but point well taken. Other comments, other people? And Victor, you're a student. Maybe you want to talk to Ian about doing some internship at Akamai? At Akamai. Akamai at Google. I'd talk to Ian about doing some internship. Well, you could go to Akamai too. It's actually their neighbors. If maybe you're interested in being grinded. Other questions?
Very so compelling.
If you want to suffer, go to Google. That should not be part of the minutes. No, I think you. Yeah, well, yeah, you. No, I actually one time I said that next generation internet should be for dysfunctional family, and actually made it to a minute somewhere. So and it was tweeted 3 times. So anyway, no, and looking at I think Ian seems to be doing fairly well. So I think it's a good job. So anyway, thank you so much, guys.
Yeah, thanks a lot. Okay, we are just on time. That was a 2-hour session.
There's a lot of bad connotations there.
If there's anybody see the blue sheet, everybody sign.
Stream ID.
Yeah,
the identifier for the range of the application. I think that's the primary piece. And so,
Where do you do Sunday? Yeah. So I think it's really well received.
For us, where we have a tunneling layer so we have a very stimulating.
Yeah. So I mean, the only other way I could think of doing it really is to do it on a package.
Well, not this.
And that also works. But then
I think we should put out.
you end up having to do, and we kind of